All right, welcome back to the shop. I'm out here today. It's Thursday. It's a little bit of a rainy week this week, so I got some work done in the shop, and I'm not gonna, you know, misbehave like I did in my last video. But I want to show you some projects I'm working on. Generally, if a project causes me to get stuck, I just leave it alone for a while and then I come back to it, which is why I have 50 on half painted armies right now. My focus right now is generally on stuff that I want that I can't get in any other way. So if it's not available and I can't get it, then I'm going to make it myself, and then try to share it with people if possible in one way or the other, with either videos or STL files or making a product and offering it for sale at a reasonable price. I'm not doing a lot of gaming stuff right now because there's a lot of stuff out there. I don't want to get into the current mode of the Kickstarter hype FOMO, which seems to be the process. At some point, perhaps someone will want to collaborate on something, and that'll be different. I'm going to leave that stuff for a little bit later on because I have so many things to paint, so many STL files, so many projects that I don't need anything else. And I'm starting to get over the desire to just constantly just accumulate. So what am I working on in the shop? This week I worked on my 125th scale driver mold because I've been making model cars into slot cars, and I'm running out of people to put in them. So I made a mold, and I'm going to put that clip in right here. So this is a block that's been in the mill for a couple days. You can see I had to remove a lot of material because with an organic parting line or anything that you have one part that needs to be raised up, you got to remove everything else. So this is my Z or zero down here, flat plate. Then the organic parting line has to rise up to meet the widest part of each of the individual pieces. This is an arm back here, and the parting line goes up. I'm going to show you what goes in here, but if I take some clay and I press it in here, you can see that there comes an arm with fingers and a hand. And so hopefully when that is done, the other side will match up perfectly, and I'll get that out of there. Over here we've got the back of the guy's head with some hair on it. There's a spot where the clay didn't. But this is kind of how I test to see what stuff's going to look like. There's a guy with long hair, kind of an 80s or 70s hair type thing. Up here we have the woman, her torso and her head are together, and that's going to be the back of her. And then those cavities are going to be sockets where you put her arms in because she's wearing like a tank top, halter top. And there's her arms, and there's like a ball on the end of it that'll socket in there. Hopefully it'll make it so that you can move her arms around a little bit and position them closer to the shifter or whatever you need to do to position them how you want to. I'm going to get a close up here real quick, zoom in, and you can see that's kind of what it looks like. So that's what the mold looks like. Now I'm going to go into the CAD files, and I'm going to show you the design and layout that went into prepping this. All right, so these are the meshes that I picked out of the mold, and the rest of the mold is hidden. But the torso for the guy should look like that. Should make it very easy to paint because there's just one solid color for the t-shirt. The neck and everything is separate. His arms are in a gripping fashion. They're just mirrored. It's the same arm mirrored. And they glue on here, and you should be able to twist them so that you can move them closer to the shifter or closer to the steering wheel. The woman's in a similar situation. You can see this. Her tank top has the arm sockets cut out, and then I've created basically two shoulders that go in there. Probably should have smoothed those spheres out. And then here's the guy with the hippie hair, guy with a regular haircut, and then this guy has a beard and eyebrows, kind of like an older version of that guy there. And of course we got the helmet. And essentially I did all the back sides of everything. I took this woman and chopped this hair off and ZBrushed some hair on her because, okay, so here you can see the parts all rested into the block that I started with, and you can see the parting lines around here, and that I showed you at the beginning. That's the parting lines right there. I'm gonna have to probably try to edit this video to make it a little bit more common sense. And what else am I working on? I worked on my 132 driver tray, and I'm going to show you the problems that I had with it, why it ended up back in the mill, and how I'm going to fix that. As always, there's some flash that I got to work on. I then put it on the EDM and burned it down. I didn't like this torso. Tried to pick it out with a file and it ruined it. The roll bar is actually high for some applications. You have to snip it off in order to set it in properly. And the back side of this arm right here, you can see that, is flat. I didn't mill that arm out. It's supposed to be round on the backside like this arm, but it's flat. It's just a flat arm. So I had to fix that. So that's got to go back in the mold to be repaired. And I'm actually going to enlarge everything a little bit to try to redo this. I did fix the arm. So that's that mold. In the design laboratory, this is a 1/32 scale chassis that I 3D printed and I designed in Rhino. And I'm going to tell you what's unique about this, or not unique, but just kind of different because I wanted something different. It's a direct drive chassis. It's a dual shaft motor like this with 2mm shafts on the end of it. So I got these little pulleys off of eBay. They're for 3D printers. They go on the 2mm shafts, which is whatever. And put them on. Put some hub adapters on, and I got some Arton tires mounted on here. I'm going to try a direct drive chassis. It's going to be slower accelerating, higher top speed, but I kind of like the slower acceleration. It gives you a little bit more realistic because a real car can't do 0 to 60 in -8 seconds. And I generally will crash most often by giving it too much power and then it spins out. So this is a direct drive chassis. It has the opening for the cars and chip. It has the sliders like I like for adjusting, one on each side. This time I put them on the top rather on the side. And then it has the front section. Now the front section is where it's a little bit interesting that I got to work on some things. The front section is a wobbler guide. I saw a guy several years ago who was selling these on Shapeways, and he didn't answer my emails and he kind of disappeared. His was not like this. His design was similar, but basically the idea is so that the guide, here's the guide, it's a Carrera Evolution, or exclusive guide, I believe. It's one of their older guides. You can get them. The guide can pivot like normal, so it can go in the slot and pivot back and forth. I hope you can see this. It's hard because my fat fingers are in the way. So it can pivot like a normal guide, like this. It can also slide back and forth so that the front of the car can move. You can look it up. Its name's Pip Slot. Look it up on you, Google it. He had a video out at one time, and he was doing all kind of neat things with these, and I thought, man, I want to really try one of these. So I wanted to try one, and this is my variation of the Pip Slot. And because it's front mounted, it's going to be self-centering, and it's just going to allow the front of the car to wobble back and forth. Now, I was going to use stub axles, but they're not working right. And the stub axles were supposed to act as a stop for the wobbler bar, so that the wobbler bar could only go over so far and hit the stub axle. That's not really working for me. So I'm going to have to instead modify the wobbler bar and make it so that it can clear a straight through axle. And the way this works is, I mean, the front end slips on here, you put a screw in there, and you can tighten the screw down to limit the amount of wobble, how tight you want it to be or how whatever. This part rubs right inside that groove. You see that groove right there? Yeah, this part's going to rub right inside the groove. And then when you put this on and you put a screw in the top, it has a little tiny lip that prevents it from lifting up. So there you have it. You have a wobbler. So this is what I call my wobbler chassis, wobbler direct drive chassis. I'm going to do some testing on this. Maybe I'll run this weekend. I just got to 3D print a different bar. So that's one design there. I want to experiment with direct drive for 1/25 scale. So this is a motor I got, I think $3 I paid for these, $350, $380, something like that on eBay. Huge torque motor. I'm going to try to direct drive my 1/25 scale cars, and this is the one for 132. I've had this for a while. I don't know where I got it from, but I have this bookmark, so in case I need another one. I asked them, I said, can you supply these in quantity? And they said, yeah. So if I'm going to design the same thing, same grabber chassis. So that's that. One of the things about these direct drive, these motors have a 2mm end to them, and you can buy 2mm axles. They're very plentiful and they're really cheap. You know, 2mm axles are everywhere. 3/32 axles are more common for 1/32 cars, and then 1/8" axles. So what I'm going to do is build myself a hub that'll go for those tires, and I might build a hub to go for my scratch builds because I'm having a really hard time 3D printing hubs that don't wobble like crazy. When I glue the hubs together, hub adapters, oh my gosh, some of my cars are hopping up and down. They're just not they're not round. So what this is an ejector sleeve. So you have I'm going to take these 1/8 inch rods, and I have 6 of these I bought. These are actually a little long. I'm going to cut them off and then weld this piece back on. But this rod, I'm going to take and get three different rods for each of these. Put it in here, and about the very end of it there, just a little bit at the end, and I take a lathe and turn that down till it's 2 millimeters. Then I can put this particular rod in the sleeve, make a hub, and it'll press off because the sleeve presses off and pushes the hub off of, off the pin here. Then I can replace the pin, get another, take another set of pins and use a lathe to turn them down to 30 seconds, pop them off so that I can use them for 1/32 scale car builds. And then again, just leave the 1/8 inch and boom, pop that off. So with one hub mold, I should be able to make it so that you can press it on the 2 millimeter axle and then just change the pin and then shoot a bunch of them and put them on the 3/32 axle. And so that shouldn't really be a problem. Essentially, in order to make this tire, I got to make a sleeve as big around as that tire, and the inner pin as big as that. And that's definitely going to be a lot of lathe work. I do not own a lathe, but I'm going to try to trick my CNC into thinking it's a lathe by relabeling the axes with different letters and trying to run a program. I think it'll work. So this is an Arton tire, and I can fit these onto the Carrera NASCAR, the classic NASCAR, and they're a good fit for street cars, and they can fit onto the Pioneer cars. They're not the exact size as any of them, but they're usable. I like these a lot, so I'm going to try to replicate this tire in TPE rubber. I think I found a source. I'm still crossing my fingers and hoping that they don't flake out on me. But I think I found a source, so I'm going to buy some of that. It's going to cost me a couple $100, and then I got to build the molds for it. And then the molds built for this it took me a long time to figure out how in the world they make this. How do they make this tire? And I think I got it sorted out. But that's a couple different things I'm working on right now. You can see he's got a bunch of molds stacked behind me that are done. So this is the old Mercury Cyclone mold that I made a long time ago. And I haven't been able to replicate this. But I wasn't happy with the amount of flash. So essentially this is the top that comes in, and the bottom sets on here. These sides slide open. When the car gets ejected, it has to flex and pop off. So you want to have really nice thin sides so they can flex a little bit. And there you go. And it helps if you pop it off when it's still a little warm. You don't want to let it get too cold. But yeah, I got to eliminate the flash on this, so that's why I wanted to try to make some improvements, and my improvements turned out to be less of an improvement than I thought, because I never really replicated this yet. So what was next was Plymouth mold. This is Plymouth mold number 1. And it was designed to be operated the same way as the Cyclone, with the alignment bushings pressed into here, spring loaded. And I used the old brake drum springs to pop it back out. They set in here and they just plop it back open. Doesn't have to give much, just enough to pop it out. I could not get this thing to fill. No matter what I did, I could not get this mold to fill. If I get stuck on something, I can often walk away from it for a while. Sometimes I'll just sit and play solitaire and think about it. Sometimes I'll take a couple days, sometimes I'll walk away. So I devised a much better solution for this die assembly, and after months of hard work and hundreds of dollars, the results were a catastrophic failure. So now I have to repair this. Okay, Chris, this is for you. So this is the plate that you made. These are the L-gibs. There's one down here already. This one goes up at that end, okay? the L-gibs are what I'm going to anchor underneath to help with the sliding. Let's put the Plymouth satellite mold core in here. Underneath each of the trunnions, I put a small notch. This is stainless steel knife blade blanks. They go in here on each side. There, holds that in place. Okay, so now we've got some wear plates down here because we're going to rub steel right on top here. We're not going to just operate on this. These trunnions have been drilled out. This is now 12 millimeter rod instead of 8. Let me put the wedge in here. This obviously is going to get tightened up. There's going to be a stack of springs in here. There's going to be a centerpiece locked in place, springs on both sides. Keep this wedge moving. So you can see how this goes. L-gib gets bolted on over here. Wear plates are now in place. Nothing can move. We're good to go. Now, this is what I want to show you. This is what's puzzling me. So this goes over, and if I bolt it in the right spot, right there. Perfect match. Goes right in up against. And slides nice and easily. Springs are going to push it back open. Here's how we're going to further improve this design, which this is what crashed on us. This broke. It was a catastrophic crash. 28 tons, everything busted up. It was a disaster. And we shelved this for a while, but we're coming back to it. So here's the problem that I have. So this is 13/16 steel. I need to shave it down just enough to fit underneath there, and it's just a little bit off, just a tiny bit off, because it is going to now be attached to the bottom of the wedge so that the wedge is not resting on these rods, which is resting on these trunnions. It's not going to be able to go because it's going to be smack dab up against this wear plate. I'll smear a little grease in here. It'll slide. I'm going to notch the end of it so that it goes underneath these L-gibs and stays in place. So it's going to go underneath here and lock in. So I got to cut the ends off precisely. I got to mill them down precisely, notch them a little bit, and then shave it off. Okay, simple enough. And then we're done. We're ready to bolt this baby up and see how it goes. I'm going to try to shoot this Plymouth one more time before I take it out and throw it in a pond. Here's the problem.
So here is that original die design in Rhino. So the idea is that these parts in the center right here and right here can just be replaced based on the particular car that's being modeled. And essentially I should be able to recreate second and third cars easily. This is the trunnion that gets eliminated on that improvement and that upgrade. Now here's the wedge. Okay, it's still centered on the exact center of this. I've just enlarged the size of the rod that is going through. Let me see if I can zoom in on this. Right here, this rod just got larger, but it didn't change the location. Now here's the daggone problem I'm having. When I measure the physical model over there,
when I measure this, and I'm not measuring the wear plate, I'm just going to measure straight up here. The drawing on the computer is 886. And
this gives me one measurement of 881.
I don't understand why. I don't understand why this is different than the drawings in CAD.
So either this drawing is wrong or that model is wrong, and it doesn't make any sense because you can clearly see that when the side goes over, it matches perfectly. So here's the Plymouth nested in here, right? And this is the surround for the whole caboodle here, whatever. It's nested in there properly. It fits in the physical model. It fits in here, yet the two measurements are different. So if I take and cut my metal to this, it'll be accurate to the drawing, but it won't fit over there. If I cut my metal for there, then all my drawings are screwed up. So I think that what we're going to have to do is just cut for there and then modify all my drawings, which doesn't make any sense. And I'll tell you what's really screwed up about this, which has got me confused. And this is one of those situations where I'll probably go play solitaire for a while and think on this. This measurement is correct. This measurement is correct. The thickness of the wedge is correct. You know, everything else that I measure is exactly accurate. However, so this is right. This trunnion base is right. The trunnion location is right. The rod here where it slides is right. Everything's correct. Everything's right. Everything measures exactly, but when you put it together, it doesn't measure. I don't know why that is, and I have to figure that out because
So I think I'm going to finish putting the driver into this Mustang, and maybe something will come to me as I work through this. Um, and maybe it's just I have to just edit the drawings, but I don't understand why. And I might just sit at my little painting desk and look out at the shop in the rain and finish up these orcs. All their mounts have been done for a while. They're all flocked and magnetized, and I just need to get the guys back up there. So, you guys have a great weekend. Thanks for watching.